Purkinje effect, also known as the Purkinje shift or dark adaptation, is the propensity for the human eye's peak sensitivity to shift toward the blue end of the color spectrum when exposed to low levels of light. Under different degrees of illumination, this phenomenon introduces a change in color contrast. For example, geranium flowers appear bright red against the drab green of their leaves in direct sunshine, but the contrast is flipped when viewed dusk, with the petals appearing dull red against paler green leaves.
In physiology, effect occurs because yellow light is most sensitive to the color-sensitive cones in retina, whereas green-blue light is most sensitive to the rods, which are more light-sensitive and thus more essential at sunset, but do not differentiate colors. This is why, when exposed to low level of illumination such as moonlight, we become visually colorblind. The Purkinje effect occurs at the transition between photopic cone-based and scotopic rod-based system. When intensity fades, the rod takes control, and before color fades completely, it moves to the rod's peak sensitivity. Red lights are employed in instrumentation panels because of the same lack of sensitivity to red. The red light does not interfere with night vision since the rod do not respond.
The reason why we cannot see warm colors such as the red, orange, and yellow at night is because of what we call the Purkinje effect. As our surroundings get darker because of the nighttime or dawn, the way we see warm colors or the intensity of warm colors that registers in our eyes decreases because the cones of our eyes are more sensitive to red than it is to cool colors. In contrary, colors such as blue, green, and purple are more vibrant than it is to warm colors. So example is when we see a flower at night, or specifically a red rose or a gamamella, we can notice that the leaves are more brighter than the petals of it. It is because of what we call the Purkinje effect.
Why does Purkinje effect occur? The effect occurs because the color-sensitive cones in the retina are most sensitive to yellow light, whereas the rods, which are more light-sensitive and thus more important at dusk, but which do not distinguish colors, respond best to green-blue light. That is why we become virtually colorblind under low levels of illumination, for instant moonlight. The Purkinje effect occurs at the transition between primary use of the photopic, which we call cone-based, and scotopic rod-based system. As intensity dims, the rods take over, and before colors disappear completely, it shifts towards the rod stop sensitivity.
The Purkinje effect is the tendency for the fixed sensitivity of human eye to shift towards the blue end color of spectrum at the low level of illumination. In psychology, the effect occurs because the color-sensitive cones in the retina are most sensitive in yellow lights. The Purkinje effect is a phenomenon that causes people to become colorblind under the low level of light exposure. The effect occurs because the cones in the retina are most sensitive to yellow light, whereas the rods are more light sensitive and respond best to green-blue light. This is why we experience color differently at dusk than at dawn.
The reason why we can't see warm colors such as red, orange, and yellow at night is because of what we call the Purkinje effect. As our surroundings get darker by night, the intensity of warm colors decreases because the cones of our eyes are more sensitive to red than cool colors. In contrary, colors such as blue, green, and purple are more vibrant than warm colors. So example, when we see a flower at night, or specifically a red rose, we can notice that the leaves are more brighter than the petals.